Okay, we're looking at the 1.3 pre-class notes. Objectives for this section are to define and evaluate polynomial expressions and use operations of polynomials to simplify expressions. So we have some definitions in this section we want to go through. That's the first part. The numerical coefficient of a term, or simply called the coefficient, is the numerical factor of each term. So when we talk about something having a coefficient, say you look at something like 3x squared. The number in front of the variables is considered to be the coefficient. If the term is a number only, it is called a constant. So for example, just the number 7. That is considered a term, but it is also no variables there, so it is a constant. And a polynomial is our next blank. Poly means many. Nomial is terms, so it's an infinite sum of terms in the form of a times x to a power, and so this is just a generic format of writing that. They call that the general form. We would write it more with actual numbers in it, so something like 3x squared minus 5x plus 7. That is a polynomial, adding and subtracting terms together. We usually write ours in descending order, which is what I've written here. Descending order means the power of x goes down as we write it. So this is x squared, x to the first, and no x. If you have exactly one term, you're called a monomial. So that's just a special name. If you have two terms, it is called a binomial. If you have three terms, it is called a trinomial. And anything higher than that we just call a polynomial, but they're all polynomials. Each term of a polynomial has what we call a degree. For example, if you look back at my example up here, this has degree 2 for that term because it has a power of 2. This is a degree of 1, and this is degree 0 because there is no variable. So when we put something in descending order, we do care about those degrees. Now, the degree of a term is just the sum of any exponents on the variable contained in the term. So if you actually had something with two variables, this would actually have a degree of 7 for that term. The degree of the polynomial is just the greatest degree of the term that has the highest. So if you had, let's say, 3x to the fourth, y to the first, plus 2x to the third, y to the first, we would say that the degree of the whole polynomial is 5 because this has a degree of 5 and this has a degree of 4, and the bigger degree in that specific polynomial is the term that has the biggest degree. Just some general rules of things that we're going to be doing. So these are all review. Adding and subtracting polynomials. If you add, you're just combining like terms. If you're subtracting, first thing we do is usually change the sign or distribute that negative throughout the parentheses and then add like terms. Multiplying, we will apply what we've learned about exponents from the previous section 1.2 and the distributive property. And you multiply each term of the first polynomial by each term of the second and then combine like terms. Special products, you may remember this from previous classes or previous material. FOIL is just a special name for multiplying two binomials together. So if you have something like x plus 3 times x minus 2, first means multiply the first thing in each parentheses, so that would be x times x, which is x squared. Outer means multiply the things that are farthest away from each other, so the x and the negative 2. Inner means multiply the two inside numbers together, so that'd be positive 3x. And last means multiply the last thing in each parenthesis, so that's 3 times negative 2 or negative 6. Then we would combine like terms, which that means we add the two things in the middle since they both have x to the first. 3 plus negative 2 is positive 1 or just positive x, and then bring down the minus 6. If you're squaring a binomial, we'll actually do something with this in a minute. There's a special formula that come out, so I'll go over this one real quick. If you're squaring, say, x plus 2 squared. That means you write it twice. You don't just square the insides. That's not like what we were doing in section 1.2. In 1.2 we were just squaring everything. What changed is now we have a plus sign in here. So this is actually FOIL, or distributing. So this would be x squared plus 2x plus another 2x for the inside terms plus 4. So notice you get double the middle, and that's what they're trying to point out in this formula right here. You square the first one, you multiply the two things together and double it for the middle, and then you square the last term. But it's the same thing as multiplying it out by hand. Just using this shortcut, it's just trying to get you there quicker. If it's a minus sign in the middle, then the middle term will be negative, so that's the only difference there. If you multiply two things that have different signs in the middle, but they're exactly the same numbers, so like x plus 3 and x minus 3, notice what happens when we distribute or FOIL. We get x squared. X times positive 3 is plus 3x. Negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9. You get combined like terms in the middle that are opposites, so you just get x squared minus 9. So when you have the same two values but opposite signs in the middle, you have what we call the middles canceling out, and you're left with just the parts that were squared. Dividing a polynomial by a monomial is pretty easy. You just split it into separate fractions and reduce them. We'll see one of those in a minute. We'll do harder things later on. In Chapter 4, we will teach you how to do long division. Okay, so we're at our examples now. So we're just simplifying. This first one is a subtraction problem. The first thing I do when I encounter a subtraction problem is I write down the first parentheses with no changes, because it does not have any reason for changes. And I'm going to use a different color here. Let's use red. I change the sign of everything in the second part. So negative times positive would be negative 8x squared. A minus a negative would be a plus x. And minus a negative would be a plus 2. So that's the first step when you're wanting to subtract two polynomials. You just change all the signs of that parentheses that has the negative in front. Then you look for like terms. Well, 6x cubed, there's no like terms to go with that. The x squared, that's negative 2 and negative 8 added together, so that would be negative 10x squared. X to the first plus another x to the first would be plus 1 plus 1, so that would be plus 2x. Notice it doesn't turn into x squared. We are not multiplying here, we are adding. And then negative 2 and positive 2 would actually cancel out. So this is our final answer. Okay, we have a combination of things going on in here in B. We have a FOIL property, a distributive property, and we're adding some things. So let's do the FOIL property first. That would be 3u squared. 3u times 2 would be 6u. Negative 1 times u would be negative u. Negative 1 times 2 would be negative 2. Now we're going to distribute this. So this would be 7u times u is 7u squared, and it is positive. Positive 7u times positive 1 is positive 7u. Look for like terms. We have a 3u squared and a 7u squared. So that would be 10u squared if we add those together. 6u minus u is 5u, but then we need to also combine that with the 7u, so that would be plus 12u altogether. And then the negative 2 has nothing to combine with, so it just gets brought over as part of the final answer. Okay, we have a multiplication problem here. This is a binomial times a trinomial, so 7x needs to go to everything in the second parentheses. So 7x times x cubed is 7x to the fourth, because it's 1 plus 3 more. 7x times negative x squared would be negative 7x to the 1x plus 2 more would be 3. 7x times 6 would be positive 42x. Now we want to do, let's change colors, let's do blue. Negative 4 times everything in the second parentheses. So negative 4 times x cubed would just be negative 4x cubed. Negative 4 times negative x squared would be positive 4x squared. And negative 4 times positive 6 would be negative 24. Look for like terms. We don't have anything to go with 7x to the fourth, so that would just come down. We do have some x cubes, so that's negative 7 plus negative 4, so that would be negative 11x cubed. We have an x and an x squared, so those don't combine, so actually we can mark that out. Do we have an eraser? Just erase that part out right there. It's not combining with anything. So we do have a 4x squared. That would be the next lowest power. We have a positive 42x, and we have the minus 24. So not every time will everything combine. Okay, now we're looking at a division problem. If it's just a single term in the bottom, you can think of this as separate fractions with the same denominator. So we can split this up into each of the top terms divided by the bottom term. Notice, pay attention to your signs because they're going to go in the middle of the fractions. So that is what we have right now. We just split it into 3 separate fractions, all having the same denominator of 3ab squared. Okay, if we reduce, 3 goes into 6 2 times. 1a will cancel and leave us with 2a's. 2b's will cancel and leave us with 1b. So my first term is everything is still on top. It's 2a squared b to the first. 3 goes into 9 3 times. 1a will cancel with 1a. And the b's completely cancel out. So this is just minus 3a. 3's cancel out completely. A's cancel out completely. And 2 of the b's cancel with 2 of the ones on top. So it's just plus b squared. It is possible when you're working these out that sometimes what you have left might be in the denominator. So just be careful about that and make sure you leave it where it's supposed to be. Okay, let's look at E. E has us just multiplying 2 binomials together. So this is x squared times x squared, which would be x to the fourth. X squared times negative 16 is negative 16x squared. 1 times x squared would be positive 1x squared, or just plus x squared. And 1 times negative 16 is negative 16, like terms in the middle. So my final answer is x to the fourth minus 15x squared minus 16. Okay, this one has us writing something twice and then foiling it out because it's being squared. Move this down a little bit. Okay, so if we want to square this, this would be 2x squared plus 5y squared times another 2x squared plus 5y squared. 2x squared times 2x squared is 4x to the 2 plus 2, so that would be 4. 2x squared times 5y squared is positive 10x squared, y squared. 5y squared times 2x squared is another positive 10 x squared, y squared. And 5 times 5 is 25, with y squared times y squared being y to the fourth. Combine the middle terms, we get 4x to the fourth plus 20x squared, y squared plus 25y to the fourth. Final answer. Okay, and that takes us to our very last problem, which is a little bit lengthy. It is being cubed, so that means that if you were to write this out, you write 3x's minus 4y's. And when I'm doing this type of problem, I usually do this in stages, so I'm going to FOIL this first and just bring this down. So I'm only worrying about 2 of these at a time. So this would be 3x times 3x, which is 9x squared. I'm going to go ahead and work the outer and inner so I don't have to rewrite this a couple times. That's a negative 12xy, and that's another negative 12xy. So that's my outer and my inner. So that makes negative 24xy. And then negative 4y times negative 4y would be positive 16y squared. Okay, so we're not done. We still need to distribute the 3x times everything and then the 4y times everything. So if we do 3x times 9x squared, that would be 27x to the third. 3x times negative 24xy. So we need to know what is 24 times 3. I don't have my calculator with me, so we're going to do it old school. 72. So that's negative 72 x squared y, because you have an x times another x and you have a y. And then 3 times 16 is positive 48, and we have an x and a y squared. So that is 3x times each of those 3. Okay, let's change colors so we can keep track. Now I'm going to do negative 4y times everything. So negative 4y times 9x squared would be negative 36 x squared y. Negative 4 times negative 24, so let's see what 24 times 4 is. That's 96. That'd be positive 96 because it was negative times negative. And it is an x and then a y squared. And then 16 times 4, which is 64. So that's negative 64, and then we get a y times a y squared, which is y cubed. Okay, so now we're looking at, do we have like terms? Nothing to go with 27x cubed, so that's just going to be combined as one big term that it already was. Let's see. This is an x squared and a y, and so is this. It has to be the same exact variables with the same exact powers. You can't use 48 and 96 because they both have x to the first and y squared. So we're just adding negative 72 and negative 36 together. So that is negative 108 x squared y. And then we have the 48xy squared and the 96xy squared. Those are both positive, so we'll be adding. And that is 144 xy squared. And then bring down the minus 64 y cubed. So that one was a little long, but again, it's the same properties, same principles as everything else in the section. You just had to do a little bit more work to get to the final answer. And that is the end of the section 1.3 pre-notes.